Hi, welcome to our Unit 7 in our chemistry units, and in this unit we're going to be talking about acids and bases. To start off the unit, we're going to learn about properties of acids. First, acids are electrolytes, meaning stronger acids are good conductors and weak acids are poor conductors. Next, they react with metal to form H2 gas. Next, they react with bases, OH minus, to form salt and H2O. They have a sour taste and are sticky. Strong acids ionize completely in H2O. Now, how do you know if something is a strong acid or not? I'm going to list all the strong acids right now. We have HBr, which is hydrobromic acid. We have HI, which is hydroiodic acid. HCl, hydrochloric acid, and HCl4, perchloric acid. If it's not one of these, then it's a weak acid. So these five you see over here are the only strong acids that we're going to use. Alright, if it's not one of these, then it's a weak acid. Weak acids do not ionize completely in H2O. Weak acids do not ionize completely in H2O. And we're going to now learn theory of acids, some series of acids. First, we have anhydrous acids, and they produce H plus in H2O. For example, HCl breaks down into H plus and Cl minus. Now, our second type is Bronstead, Lowry acids, and this one proton donors. Which is hydrogen donate protons. Protons are donated one at a time. H plus is a proton by itself, since its neutral form only has one electron. Now, in its ion form, it no longer has its electron, meaning it's pretty much a proton sitting by itself. An example of Bronstead-Lowry acid is HSO4 minus plus H2O makes, let's see, this H is a proton donor, so it will donate a proton to this. And now what would that form? H2O having received another hydrogen will become H3O. Now this time will be a cation because of the extra proton, plus SO4. In HSO4, the H is gone because it donated itself to the water. So now this will be SO4, and then the charge will become 2 minus since the cation hydrogen will be gone. And this is an example of hydrogen donating a proton. Now we also have three types. We have monoprotic acid, which has 1 proton. And this is similar to the example we just done. Let's do another one. HCl plus H2O. The H gives its proton to this one, and now that gives you H3O plus Cl minus. Now second one is diprotic acid. This has two protons. An example of that would be H2SO4. Notice I have 2 hydrogens plus H2O. And remember in the beginning we said hydrogens donate by proton donors. This is supposed to say proton. Proton donors / hydrogen cations are donated 1 at a time. Alright, so first we're going to donate 1, and this is going to become HSO4 minus plus H2O H3O plus. Now we're going to take a hydrogen product over here, which is HSO4 minus, and add it to water 1 more time. Now this hydrogen will be donated again to form SO4 minus plus. No, S4 2 minus, because remember this is 1 minus when bonded with hydrogen, so without the hydrogen it will become 2 minus plus H3O plus. And our final type is Diprotic acid. And now this has 3 protons. Now I'm going to zoom in a bit to show you the last example. So let's say we have H3PO4 plus H2O. Now hydrogen will donate to H2O to form H2PO4 1 minus plus H3O pluses. Now we're going to use this and add it to water 1 more time plus H2O. Hydrogen will donate itself again to form HPO4 2 minus plus H3O plus. And finally we're going to take this, bring it to our third equation, HPO4 2 minus plus H2O, and hydrogen will donate itself 1 last time to make us PO4 3 minus plus H3O plus. And that is it for the different properties of acid, different properties of acid. We're going to talk more about how acids give protons and bases accept protons, and how you work out these more specifically in a future video. Thank you for watching.